So this presentation is about estimating the population mean using technology. In this case, we're going to use Excel in the situation where the population standard deviation is known. Okay, now that's not an especially realistic situation. Usually, if you're trying to estimate the population mean, you're making an estimate because you only have access to a sample. You don't have access to the entire population. So most often when you're making an estimate for the mean, you would not know this population standard deviation either. And we'll talk about that more realistic situation a little bit later in a different presentation. But this one's easier to understand, and we'll have some situations later in the semester also where we're testing a hypothesis. So although we don't know the population standard deviation for sure, we may have some guess about what it is. And so we're coming into the situation, into this story, where we either know it or we're pretending that we know it. Okay. And we learned a formula in an earlier section for the margin of error. So we learned to do this by hand. And what I'm really just trying to introduce with this presentation is an Excel function that can do the arithmetic for you. And I'm just going to emphasize as I go along what are the requirements for when does this work? When is it a valid method to use? So the function's going to be this confidence.norm function in Excel. And what it's finding for us is the margin of error E. We calculated that with this formula here in an earlier section. Okay. Oh, and by the way, this is in the OLI textbook. This would be modules 13 and 14. In our workbook for the class this November of 2020, in the current edition of the workbook, this is starting on page 428. Okay. So, when is this useful? So you want to estimate, it's when you want to estimate make this a little bigger, you want to estimate the population mean of a random variable. You don't have access to the whole population, you just have a sample. And what you're trying to figure out is, if you do go out and get a simple random sample from the population, you get the sample mean, how close is it likely to be to the true population mean? This margin of error that we're going to calculate, we're going to work out for our example, okay, 95% of all samples will produce a sample mean not more than this distance away from the truth. So we're trying to calculate that distance, that margin of error. When does this method work? So you have to know the population standard deviation to get started. And the validity conditions have to be met. What are the validity conditions? There's two of them. You have to get a simple random sample, not any other kind of sample, and the variable must be either roughly normally distributed, that means symmetrical, unimodal with no outliers, or the sample size has to be big enough to compensate if it's not normal. Sample size in the low 30s is always big enough. Bigger is always better. Okay. So you don't have to have both. It's just roughly normal, or you have a big sample. One or the other of those two conditions, A and B here. But it has to be that you're working with a simple random sample. Now, so let's I just want to illustrate how to use this Excel function with a story problem. So suppose the mass of peanut butter cups is normally distributed with a population standard deviation of 2 grams. Then 95% of all possible simple random samples of, let's say, size 16 will give a sample mean that's not more than how many grams different from the true population mean. So if everybody in the class, if each person got their own 16 peanut butter cups and weighed them all, each person could get their own sample mean. They're all going to be a little bit different. But most of them are pretty close to the true population mean for all the peanut butter cups in the world. So 95% of all possible simple random samples are within some distance away from the truth. That distance, that's what we're trying to find. Step 1, you decide whether this z-based, this normal distribution-based method is the right one to try. That depends entirely on, do we know the population standard deviation? Is sigma known? Well, in the story, it tells us here that the population standard deviation is 2 grams. So because we know that, or we have a hypothesis about it, that tells us to use this z-based margin of error. By that, let me refer back to the discussion over here. That's this formula for the margin of error that we learned in a previous section. If we did not know sigma, we would have to use a t-based method, not a z-based method. We'll talk about that in a separate video. But so we say, okay, we're going to try the z-based method because we know the population standard deviation. Now, are the validity conditions met? We are planning to get a simple random sample of peanut butter cups. So condition 1 is met. And condition 2, well, we're told that the distribution is roughly normal in the story. It says, suppose the mass is normally distributed. So that's enough. If we were not told that, we would need a bigger sample. 16 would be too small. But because we know it's a normal distribution, 16 is okay. So the validity conditions 1 and 2 are both met. Step 3. We're going to look at the story and see the confidence level. We want to be 95% confident that our sample mean is not going to be more than a certain distance away from the truth. 95% confident. So the confidence level, the little c, is 0.95. Now here in step 3, we're going to do our first calculation. We're going to find the significance level, alpha. That's 1 minus c. So in Excel, to make a formula, I start with an equals mark. I type in equals here. I'll do 1 minus, and I'll click on the C, say enter. So there's 95% confidence and 5% significance. So I found alpha. Okay. And then if I was working by hand, I would do this formula over here in the workbook, but I'd have to look up the critical value of z, the z star, and Excel is going to do that for me. So I'll type in equals to start a formula. I start typing confidence, and I'm doing confidence.norm, the z-based or normal-based confidence interval. And it tells me the arguments to put in here. So once the alpha, I'll just click on the 0.05. It wants the standard deviation. We were given that that's 2 grams. And it wants the sample size. Our sample size was 16. We're going to get 16 peanut butter cups and find their average. So those are the only 3 pieces of information I need to put in. I close the parentheses. I say enter. And it gives me a number. And that's a number of grams. Now, it calculates many digits. If I want to report the final result in the end, I'm limited by how accurate is the population standard deviation. So since it only said 2 grams, there was no decimal point up there. I need to round this off. I can show just 1 digit more. So I'll show, I'll say equals this guy. And then I'll adjust the format of the number. I just want to show to the nearest 10th. I'll just say it's approximately 1 gram. So what does it mean? It means whenever we get our 16 peanut butter cups and we get the average weight of just those 16 peanut butter cups, the average mass, we can be 95% confident that the truth is not more than about 1 gram away from whatever we get. 95% confident in the sense that out of all the possible ways you could pick your 16 peanut butter cups, 95% of them, 95% of all samples of size 16 will be this good, within 1 gram of the truth, plus or minus. Okay. So what's our confidence interval in the end? We're going to go out and get our sample mean. And we'll make an interval of possible numbers from whatever our sample mean is, our x bar, minus this margin of error here, up to x bar plus e, plus the margin of error. So we'll get our sample mean. We'll subtract the margin of error. We'll also add the margin of error. We get these 2 boundaries. And we're 95% confident that the truth is somewhere inside those boundaries. So in a big class of students with 20 students, they all made their own interval. Everybody gets a different confidence interval centered around their own mean. Like for the project, we're all measuring hepatitis mortality rates. Well, if you had 20 people, they make a margin of a confidence interval like this. 95% of them, or there would be 19 people, would probably have the truth somewhere inside the interval that they give, and we would expect that 1 person just wouldn't get lucky and would not. And so that's how you interpret the meaning of a confidence interval. And with the Excel function, they're easy to find. But in this story, we had to know sigma to get started. You may not know that, and that'll be a topic for another video. So that's it for this topic.